Okay, so today we're going to talk about functions. We're going to look at how to define a function, look at some attributes of functions. We're going to get into a talk about domain, and then operations on functions. All right, so first of all, definition. A function is a relation that pairs each element in the domain with exactly one element from the range. So first, let's look at a function as a mapping. And we'll look at this set as our domain, which is typically our x values. And we'll look at this set as our range, which typically we call our y values. And we'll call this function f. So f maps each element in the domain to exactly one element in the range. So maybe we'll call this 1, 2, 3. How about 4, 5? And so let's say we map 1 to 4. Then if f maps 1 to 4, we would say f of 1 equals 4. Maybe 2 gets mapped to 5. So I would say f of 2 is 5. And then maybe 3 also gets mapped to 5. So I would say f of 3 equals 5. All right, so two different ways to look at the same function. Another way to look at the function would be to look at the set of ordered pairs that would correspond to this unique mapping. So if 1 was mapped to 4, that would give us the ordered pair 1, 4. If 2 was mapped to 5, that would give us the ordered pair 2, 5. 3 was also mapped to 5, so that would be 3, 5. So again, there's this set of ordered pairs. Again, you can see the domain is 1, 2, and 3. That is also evident by looking at the x coordinates of those ordered pairs. And the range is 4 and 5. And again, that is evident by looking at the set of ordered pairs. Now I could also graph these ordered pairs to represent this function. So let's see, we would have 1, 2, 3, 4. 4 would be here. 2, 5, which would be up a little bit. And then also I have 3, 5, which would be right next to it. So this again is the same picture of this function. Most people remember to test if a graph is a function, the vertical line test. Line test. So remember, the vertical line test says if I draw a vertical line through any place on the function, it will only intercept the graph of that function in one place. So we can see that this would pass the vertical line test. So some of the questions that you'll be asked will be, you'll see a graph, or you'll see a set of ordered pairs, or you'll see a mapping, and you'll be asked to determine whether or not it represents a function. So these are the things that you're looking for. Again, each element is mapped to exactly one element in the range. So let me give you a non-example. So a non-example of a function would be if I have, let's say we have 1 and 2, and then 3 and 4. So if 1 is mapped to 3 and 1 is mapped to 4, that's what can't happen. So again, think about how that translates to those ordered pairs. I would have 1, 3 and 1, 4. So it's that repeating x that you can't have. And think about what that would look like on a graph, because I would have 1, 3, and 1, 4, one right on top of each other. So again, the vertical line test would fail. One way I keep that straight is to just really think about travel. If we are walking, so if 1, 2, 3 are walking to 4 and 5, 1 can walk to 4, 2 walks to 5, and 3 walks to 5. And 2 different people can walk to the same place at the same time, but one person can't walk to 2 different places at the same time, like down here. So those are, again, examples and non-examples of a function.